Hey there guys, it took me all day to get this sorted out because typical, yesterday it worked okay, today it's drawing more current than what it should do, so I'm going to explain the setup. In the background here, got a nice big car battery because again the unusual current drawer of today. On the side here, I don't know if you can actually see that, you can, that's the motor controller, that's the drive motor, this is a generator. Originally I thought this was a stepper motor. I saw an experiment with a stepper motor making it as a generator. I thought I'd mess around with this, but actually I found it's a DC motor. On the background here, can't quite actually see it, but there is a big rectifier in the background. Go forward, and as you can see, it's not in connection. For this motor here, it's got a lead sticking out a bit. It's from a record player. As you see, it's got loads of wires sticking out, so I thought it was a stepper motor. I've got a red, blue, black and yellow. Each one actually controls a different speed when different power is put into it. The common lead is actually not the black, which I thought it was, it's the red. So on the background here I've got a little tiny bulb as a potential load, because it's high potential. That's connected directly to the red lead, which won't change. This meter here is for the amp draw from the motor controller. It's obviously driving the motor, which I'm just going to leave it as it is. And that's going to show different behaviours of regenerative acceleration from a DC motor at really low speeds. This is a whole thing that I discovered yesterday, and it's like, what the hell? So, with the leads, yellow lead would be the slowest speed, the black lead is the middle speed, and the blue lead is the highest speed. As for a generator, this one will output the lowest voltage, the black one will do the medium voltage, and the blue being the high. I won't be using the yellow because it's just no use to it. As for the black and blue, that's where things go different. From let's see, from the blue lead, obviously being the higher voltage, would be considerable the better generator. But from the same generator, I can actually show regenerative acceleration from the same generator from just using two different leads, because of the potential difference in the coil inside. So let's get on with it. Being a sine wave generator thing for the motor controller, it's going to produce a sound, and that sound we can use is also a reference to this behaving at different speeds, and it can also visually and hopefully be seen. So I'm just going to pop that on. Again, sorry if the sound comes resonating right through the board. I've tried putting a firm mat down, but it just does what it does. So, as you can see on there, let's put myself out the way of the light. Currently it's at 2.10 amps draw, which shouldn't be that high, but it is for whatever reason today. I've got a load, obviously being the little light bulb in the background. Tiny little light bulb. It's not an LED, it's the old piece of wire. So I'm going to show first off the normal behaviours of what a generator would do. So it's 2.7 and it's running at this speed. This is what a normal generator would do. When you put it under load, slows down considerably and draws well, a few more milliamps, being only a small motor. So we're at 2.5 and it bubbles up between 2.8, 2.9. And from the same motor, using a different lead, which is the black one, this is where I get low speed regenerative acceleration. Again, it's not a massive amount, but it is happening. So we're at 2.5, 2.4. Now we go down to 2.3, 2.2. And as you can see with the blue lead, that's what happens. With the black lead, That's what happens. Very, very, very low RPM. Again, because of the power supply that I'm using and the stupid amount of current that it's drawing, well, if I speed this up, you won't see the acceleration effect. It only seems to happen at these slower speeds because it's noticeable. Again, if I increase the speed, flip to the blue lead, again the current draw, you don't notice it, and it won't light up the light bulb either. It's 16, 17. So that's why I'm actually using the very, 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 very low speeds. Normal generator mode, 1.96 odd amps, and the strange regenerative acceleration that's happening with a DC motor. One point 1.94, 1.94 to 93. Yeah. So 94 to 95. And 1.94 to 93. So there is actually an acceleration effect happening from this DC motor at low speed, which doesn't normally happen when you're putting the generator, putting a load. I'm just going to switch that off. Again, if I did this yesterday, Sod's Law, when I don't film anything, the current draw was much lower, and the effect wasn't as noticeable. It did drop by a milliamp again, because I also had it as the first discovery, as it was, a direct connection between the motor and the generator. I've put this on here obviously to amplify that, but Sod's Law that it's actually now drawing more current because of the gear ratio of probably about 1 to 6, 7, being so small. But it's just, well, again, one of those random sort of messing about discoveries that actually regenerative acceleration of a generator under a load and the right type of load actually causes it to accelerate. And this is nothing special. This is obviously not the bi-perpetuity generator, Einstein's ones. This is not, the Bedini motor running at 20,000 RPM. It's running at like 5, 6, no, probably a bit more than that, about 15 or so. But again, you don't actually need high speeds to have the regenerative acceleration effect. So I guess that's it for this video. That's all I can really show. I'd actually like to do more, figure out why this motor does it, because I've got loads of other motors and they don't do it. Like I said, never done, so that's why I've had to build certain specialist generators, but it happens with this one, and I just don't understand why. I'm kind of thinking it's more of a correlation actually between the strength of the magnets and the coils, rather than the coil acting as a capacitor at high speeds. It's not to do with the frequency, because this clearly shows that I can do it at incredibly low frequencies, even direct drive to drive, and it still works. So, one thing's every day, don't I? Pop that back on. Good draw, so 2.5, 2.4. Again, red lead to blue lead, which will be the highest voltage output. and then red leads a black lead, which will be the medium voltage output, but I'd imagine a bit more current. And I'll just show you under dead short how it behaves. So put the black to the blue. As you see, nothing happens. It's about the red wire. So I'll put red to blue. That's obviously dead short. I'll go red to yellow just for the sake of it. Again, that does nothing because it's just such a small output. And then I'll go back to red to black. So 1.96 to 95, mostly holding at 96. 1.94, mostly holding at 9.4, just. That's with the red and black lead dead shorted. Typical. Gives me funny readings afterwards. Obviously the voltage is going down. So obviously to show that obviously that's not a quirk, I will do 9.4, 9.3. So, the generative acceleration doesn't have to happen at high speeds or with really big generators or massive coils. It can happen with the right potential in the right motor, I guess. Bring the speed right down and swap the black to red. I don't know if this will affect it. I guess maybe it does have to happen at a certain speed, but yeah, speed's so low that it's not actually outputting much on the generator. Slightly. That was in red to black. So red to blue. And red to black. Okay then guys, thanks for watching. Leave any comments in the comment section. And well, take care. See ya.